The objective of this video is to give you an introduction to the concept of chemical equilibrium. The word equilibrium is another word that is used to describe the balance, a balanced situation. So what is balance? Think about anything that has a balanced state. For example, work-life balance. If you are maintaining a work-life balance, does that mean nothing is happening in your life? No, there's a lot of things happening. But for a person looking outside, it may look like there's nothing happening. But it is you who know that there is a lot of things happening in your life. So this equilibrium or the balance state is actually a dynamic process. It's not static. There are a lot of things happening, only that it looks like nothing is happening. So, very important to keep in mind, equilibrium is a dynamic process. And just think, if you don't have your work-life balance, what will happen to your life overall? It would be a catastrophe. So the whole reason why we have this equilibrium status preferred is because of stability. So equilibrium is a way of seeking stability. If a system, whether it's a chemical system or a physical system, is in equilibrium, it has some sort of stability. Now, when we describe this equilibrium, we can describe it to either chemical processes or physical processes. Whether they are chemical or physical, these processes must be reversible. If you reverse the condition, you should have the reverse product. So these processes can be chemical or physical. And they must be reversible if we are seeking an equilibrium state. So let's consider about a physical system. You have a container, put some water and immediately close it. The moment you close it, you may not have that many vapor molecules in this upper space. But with time, this liquid, let's say water, is going to evaporate. It will evaporate and you will start finding water vapor in this upper space. Now as this water vapor builds up, what happens? It's going to condense. It will condense and it will fall into this liquid part. Now evaporation and condensation, you know, they are physical processes. Why? The identity of the material doesn't change. You still have the same material, water in the liquid form, water in the gaseous form. Still it's H2O, only the physical state changed, not the chemical identity. So evaporation and condensation, they are physical processes, and when this rate of evaporation equals the rate of condensation, the speed, when the speeds of evaporation and condensation equal, we call the system to be in equilibrium. So there should be a reversible process, and there is this forward process and the reverse process. The equilibrium is achieved when the rates, the forward and the reverse rates, are equal. And that is why it was required for you to learn about chemical kinetics before we come into chemical equilibrium, because we talk about the rates of the reactions or the processes. So what happens at equilibrium? What's equal? The rates, not the quantities, it's just the rates. If you think about a chemical reaction, let's say you have two reactants. The moment you mix the two reactants, the reaction will start and it will start making the products. And as these products are made, the products will break down to make the reactants. So you have the forward process and the reverse process. When these forward and reverse rates are equal, we can call this chemical system is at equilibrium. So does that mean that you have same number of same concentrations of reactants or products? No, it doesn't say anything about the quantities. What we focus about is the rates of the two processes. Whenever they are going to be equal, we get equilibrium. Now, defining this equilibrium for a system, sometimes people get confused with this position of equilibrium. The position of equilibrium can be anywhere within this reaction. Now, let's take a simple example. In a warm day, let's say you have very warm sand and nice comfortable water. If the water is much more comfortable and sand is very hot, you can expect more people to be in water than in the beach. So let's say for every person that walked into the water, if there's a person walking out from water, and if this is the exchanging rate throughout the day, you will have the same number of people. Let's say you have a very warm day. Let's say we have the beach and water. Let's say we have 10 people in the beach and 90 people in water. If there is, for every person that move into water, if there's a person moving out from water, if this is going to be the exchange rate throughout the day, you can expect throughout the whole day there will be 10 people in beach and there will be 90 people in water. So whatever this condition, that was a very hot day. The water is nice, so you can have more people in water. Let's say the water is very cold. Then you can expect fewer people to be in water and more people to be in beach. So you can expect in beach, you can have maybe like 90 people, and in water, you can have like 10 people. Let's say again, for every person who walks into water, if there's a person walking out from water, then throughout the whole day, you will have 90 people in the beach and only 10 people in water, as long as this exchange rate is equal. So what does that mean? Based on whatever this condition, you can expect either more reactant or more product. This warm weather condition forced more people to be in water, and the cold water condition forced more people to be in the beach. This is an equilibrium state where more people are preferred to be in beach under certain condition and more people are preferred to be in water under another condition. And then there is this perfect condition that there can be equal number of people in beach and water. For example, the perfect day. Maybe you can have 50 people in beach and 50 people in water. Now this is like too perfect. Usually we do not end up with this kind of too perfect situation, but whatever this equilibrium condition, whether it is physical or chemical, the equilibrium position, this position can be anywhere within this range, so it can be affected by many factors. The temperature is just one factor that can affect the position of the equilibrium. Now we are going to look into more details about these factors affecting the equilibrium.